All right, let's take a look at example 3. The data shown represents the population of a rare endangered species of frog called the glass frog. In order to better understand the glass frog's fertilization habits, scientists performed a study and recorded the average number of frogs' eggs over the span of 44 months. Okay, so x-axis, we are dealing with the number of months, and the y-axis is the average number of eggs observed. So this is just a straight up number. It's not in hundreds, it's not in thousands, it's just that number is the number. Okay. And we are also up at the very top here told what the actual polynomial model is. That may or may not come in handy for any of the questions that we're asked to answer. Okay, so very first question, part A here, what is the domain and range of the study? Okay, now the study is the actual scientist going out in the field and counting up these little eggs. Okay, so the domain, this is our possible x values, and the domain here would be, well, we started with 0 months and we stopped at 44 months. Okay, range is the lowest number of eggs that you could possibly see, which would be 0, to the, and I'm looking at my table here, or my graph, these little, I guess they're blue diamonds, are the actual data points that the scientists collected. And the highest data point that we see here is this one. And so if I roll it back here to the y-axis, I'd say maybe 15,500, 16,000, somewhere in that range. So let's go 16,000. And so that's the domain and range of the study. All right, so this is the number of months, right? 0 months to 44 months. And this is the actual number of eggs observed. So 0 eggs to 16,000 eggs. All right. Now, part B says, what's the domain and range of the function? So the function is the actual black line that's been drawn here to, it doesn't really connect the dots, but it models the behavior to give the scientists an idea of maybe what's going to happen at month 50 or month 100, okay? So what is the domain and range of the function? Well, the domain of a polynomial function is going to be from -infinity to infinity, okay? So this graph is going to keep going to the left. This part of the graph is going to keep going to the right. It's everything, okay? So it's negative to positive infinity. Range-wise, we want to look at the lowest possible y value, which is somewhere down here, right? This is our lowest part of the curve here. So again, if I back it up to the y-axis, I'd probably say that's about -3,000. Kind of my estimate, okay? And then if we look at how high this graph will eventually go, well, this is going to keep going up and up and up. This is going to keep going up and up and up. And so we have to infinity, okay? All right, so part C here. At what month in the study were the most frog eggs observed? All right, so now this is the study, and so we want to make sure we're answering with the little blue triangle or the blue diamonds, not the black curve. So we want to be careful with which way we're answering. So in the study, most frogs' eggs observed. We're looking at this highest absolute point right here. And so if I look at this, I'm kind of thinking if I kind of go down like this, let's call it about month 24. All right, so month 24. And it also has how many eggs were recorded. And if you don't know, the symbol for about looks like a wavy equal sign. So let's say about 16,000 eggs. Okay. All right. At what month, and this is possible to have multiple answers here. That's why the little S is in parentheses. At what months of the study were there approximately 4,800 glass frog eggs observed? Well, 4,800, if I look here, would be really close to 5,000. And so basically, if I look at this and I kind of do a little line across here, let me see, it'll snap a line into place for me. Maybe. Nope, of course not. But basically, we're looking at these 3 points right there, because again, we're looking at the part of the study, not our polynomial approximation. So let's see, this part right here looks like about 3 months. Okay. Month 3. Let's see, this one is about maybe month 12. And then this one over here, let's go about month 43-ish. Okay, so if I look at grading these, because they're approximations, just keep it close. Okay. All right, so now part E asks us to use the Quartic regression. And so for part E, we want to actually, I'm going to use that polynomial that was given up at the top. Okay, we want to find the average rate of change over a very particular interval. So what I'm going to do right here is I am going to split screen with Calculate 84, because that polynomial is not something I want to try and deal with in my head. Okay. All right. So this is the polynomial I'm going to use. And I had an interval that was from 2 to 15. So what I'm going to do is I'm going to set this up 2 times. The first time I'm going to do this, I'm going to replace all of these x's with 2's. And I'm going to figure out what the function value is. And then I'm going to do it again, replacing all of the x's with 15's. All right. So let's see what we've got here. 0.2251. And then x is going to get replaced with 2. And I need to raise that to the 4th power. Minus, whoops, how about a minus? Minus 19.747. X gets replaced with 2. I'm going to raise it to the 3rd power. And then plus 528.95. X gets replaced with 2. What on earth just happened? Weird. Well, that's no bueno. All right, let's start it again. 225, 1. Okay. 2, 5, 1, 2 to the 4th, minus 19.71 or 747, 2 to the 3rd. Oh, that's weird. Okay, let's delete that. Okay. Somehow I was like having a double exponent there, which is a little bit weird. Okay, 2. Apparently this one does not like me. Okay. All right, take 2. So clearly I was having some technical issues. I don't know if you guys were paying attention to the when I was typing it in. For some reason, it was not liking multiple sets of parentheses there. So I'm going to change gears because I don't want to do this whole video all over again. And so what I'm going to do instead is I am going to put this into the calculator as a graph. Apparently I'm not going to do that either. Hold on a second. Oh, no, it is keeping going. Okay, it's keeping on going. I was getting worried that I wasn't seeing it. Okay. I'm going to make this video eventually. All right, minus 4292x plus 10,445. I hope that's all the right values there. Let's see if I can get this thing to scroll over. Of course not. Okay. So I will pop back up Notability in a second. For some reason, this is just causing some grief with Calculate 84 here. So what I'm doing right now is I have the, I'm just doing a quick double check to make sure I have all of the equation in the right places. Clearly at this point, I probably should just be using Desmos. I don't know, maybe that'd be easier. But all right, so here's what I'm going to do. I need to get the interval from 2 to 15. I'm not going to even look at the graph. I don't really care. I'm not going to worry about it. What I do want to do is get to the table of values. So I'm going to hit second and graph. That'll get me to the table of values. And I want two values. I want the value when this graph is, when x is equal to 2. All right, so if you see where I scroll down, the 2 is highlighted in pink. And so I am going to steal that ordered pair. So it's 2, 3822 point. I'm just going to call it 4 and call it good enough. And then I'm going to slide on down until I can get to 15, which takes a little bit of time, but not too bad on this part. All right. And then we have 15 and then 9,828.3. Okay. I'm going to slide this. I'm going to clear out the graph. Maybe. All right, I'll quit out the graph. Clear it there. Okay. And what I'm going to do here is now use average rate of change, which, remember, it's just slope, and I'm going to find the slope between these 2 points. So take one of your y values, okay, subtract your other y value, divided by your x values subtracted as well, okay? So let's see, 9,828.3 minus 3822.4. Okay, so that gets me 6,005.9 over 15 minus 2 is going to be 13. So now if I divide these two, divided by 13, I'm going to get something approximately 460. I'm going to go ahead and round that to 462. Now at this point, I'm going to go ahead and get rid of Calculate 84 here. So I'm just working with Notability, okay? Because there's a second part to this problem that says explain the meaning in the context of the problem. So first thing I want to recognize is this is positive. All right. Second thing I want to recognize is this interval is from 2 months to 15 months. Okay. So from month 2 to month 15, the average number of frog eggs was increasing by 462 eggs per month. Okay, so a couple of things to recognize. You need to tell me a little bit about the interval. So from month 2 to month 15, you need to tell me if this is increasing or decreasing. So it's increasing because it's positive. And you need to make sure that you identify that this is per month. Okay, so this is not from 2 to 15. It didn't just go up 462. It went up 462 per month. Okay, so that's a lot different than over the entire interval. All right, I believe part F is going to be the last part of this problem. Let's see, to use the Quartic Regression to determine average rate of change over the interval 31 to 34. All right, so I'm going to hope that Calculate 84 will be useful this time. All right, so I'm going to go ahead and slide it over just a touch. All right, I believe, yep. So my equation is still in Calculate 84, which is kind of nice because now I'm going to still go back into that table of values. So second graph. And all I'm going to do is scroll down until I see x is equal to 31. And I'm just hitting the down arrow. All right. So I have an ordered pair here that's going to be 31, 5,315.7 if I round. And then 34 was the other end of my interval. and 34 is right here. So 656.3. Okay, so I'm going to quit out of that. All right, so one of your y values, subtracting your other y value. And then because I picked the 656 first, that means I'm going to have to go with 34 first for x. Okay, minus 31. All right, so 656.3 minus 5315.7 gets me negative 4,659.4 divided by, what is that, 3? All right, so if I divide by 3, I'm going to get an answer of approximately negative 1,553. Okay, so that's the average rate of change. Let's go ahead and close out the Calculate 84. And then again, it says explain what's happening in the context of the problem. So from month, hold on one second. Let's go there. Okay, so from month 31 to month 34, the number of frog eggs was decreasing by 1,553 eggs per month. Okay, so again, I've identified the interval. So this is months 31 to month 34. Because this average rate of change was negative, that's going to be a decrease. Okay, and it's got to be 1,553 eggs per month. Okay, so hopefully you have better luck working with Calculate 84 than I did. It is entirely possible. Well, it is absolutely user fault. So hopefully you use the calculator better than I did. Let me know if you have any questions or concerns about that.